When Starship Flight 11 officially came to an end, it also marked the close of SpaceX's brief 10-month era of the version 2 Starship. Though this phase was short, it provided SpaceX with all the crucial data they needed to move on to something far more advanced, Starship version 3. According to Elon Musk, this next-generation vehicle could soon be used for experimental missions to Mars, possibly as early as next year. So, how exactly is Starship V3 engineered to make that possible? Let's find out in today's episode of Alpha Tech. After Starship Flight 11, the final launch of the year, there's no sign of rest at Starbase. Instead, workers are pushing full throttle, tackling a massive list of upgrades and construction projects, all aimed at preparing for what could be a breakthrough year for the Starship program. At the production site, just beside the megabays, SpaceX has begun vertical construction on the new Gigabay, the largest building ever built at Starbase, designed to boost and streamline Starship manufacturing at an even greater scale. A few kilometers away, over at the launch pad, crews are taking apart Pad A piece by piece. The chopsticks on the launch tower are being dismantled, the OLM's foundation is being removed, and even the fuel lines and blast berm are being torn down. The tank farm and other support systems are also expected to be replaced, part of a full-scale reconstruction to make the entire site ready for Starship version 3. Speaking of that new version, on October 21st, observers spotted the nose cone of Ship 39 being lifted and aligned for stacking onto its forward dome section. This marks the first Starship V3 currently under construction. Still, Ship 39 has a long way to go. Structural welding, hardware and plumbing installation, interior outfitting, completing the heat shield, and of course, cryogenic testing and static fire trials. Realistically, 2 months won't be enough, especially for the first vehicle of this new generation. But that's fine, because SpaceX is taking things slow on purpose to overhaul Massey's site, the launch complex, and the production line, all in preparation for something big next year. And what exactly is that breakthrough? In 2026, SpaceX plans to achieve several firsts. The first orbital flight of Starship V3, the first in-orbit refueling test, the first Mechazilla catch of an upper stage, and potentially the first uncrewed mission to Mars. These aren't rumors. They come directly from Elon Musk, who wrote on X, V3 can get to Mars and might, but V4 is more likely. That statement aligns perfectly with SpaceX's current schedule. Starship V3 is expected to debut later this year, with the first test flight set for 2026. Musk also confirmed to space journalist Eric Berger that SpaceX will do orbital refilling several times next year with Starship V3. Once SpaceX masters orbital refueling, it will likely send an uncrewed Starship to Mars to push the vehicle's limits and gather critical data for future crewed missions. But the question everyone's asking now is this: what kind of upgrades has SpaceX built into this version that make it capable of handling so many critical missions, including, potentially, a mission to Mars? Of course, the answer is a lot. Compared to version 2, which saw 5 dramatic test flights in 2025, with only the last 2 succeeding thanks to major heat protection and reusability improvements, version 3 introduces a full-scale redesign. The entire vehicle is now taller, standing about 124.4 meters, up from 123.1 meters, with a slightly lengthened Starship and a 1.3 meter taller Super Heavy booster to accommodate much larger propellant tanks. Starting with the booster, SpaceX has pushed it to the absolute limit, fitting 33 upgraded Raptor 3 engines, each generating around 280 tons of thrust, up from 230 in the original and 250 in Raptor 2. That's an enormous leap, 95 tons more than the first version and 50 more than the second. Combined, they deliver a theoretical 8,240 tons of thrust, though SpaceX's goal is a full 10,000 tons at liftoff. For perspective, that's over twice the power of the Saturn V, making this the most powerful rocket stage ever built. And that power isn't just for any competition. It allows Starship to reach higher orbits faster, carrying more fuel in the upper stage for orbital refilling. In turn, that reduces the number of refueling flights needed for deep space missions, like those to the Moon or Mars. We're talking about up to 3,650 tons of fuel and oxidizer in the Super Heavy, plus 1,600 tons in the upper stage, a total of 5,250 tons of propellant per launch. That's a big leap from the 4,750 tons used in version 2. The extra fuel is needed to feed those powerful Raptor 3 engines, maintaining full thrust throughout the entire boost phase, which lasts several minutes. This also allows all 33 engines to run at maximum power, giving the rocket more lift, longer burn time, and greater payload capacity, even for the most ambitious deep space missions. To make room for all the extra propellant, SpaceX extended the booster itself. Version 2 stood around 71 meters tall, while version 3 measures 72.3 meters. Inside, the new design features a massive transfer tube that carries liquid methane from the top of the booster down to the engine bay. To give you an idea of scale, that single tube is almost as large as an entire Falcon 9 stage. Interestingly, even though the rocket is taller, the diameter remains unchanged at 9 meters, consistent with all Starship boosters so far. Another major internal change inside the booster lies in the liquid methane tank, which now features additional internal reinforcement. In the previous generation, the tank had over 70 internal stringers. Those are metal support beams attached to the tank wall to improve structural integrity. But in the new booster, SpaceX increased that number to 96 stringers, providing extra rigidity to handle higher pressure and dynamic loads during ascent. The reasoning seems clear. By adding more internal supports, SpaceX could eliminate the external reinforcement rings near the top of the tank, freeing up room for the new integrated hot staging ring. The new booster structure is also more modular. It now consists of 3 stacked barrel sections, internal stringers, a segmented dome, trusses, and a top structural ring. This upper dome isn't just the hot staging interface, it's also the top of the methane tank itself. Everything below that dome belongs to the methane tank, including, interestingly, the grid fins. That presented a new engineering challenge. To prevent the super cold methane from freezing or damaging the grid fin mechanisms, SpaceX designed a sealed enclosure around them, isolating the fins from the cryogenic propellant. It's a smart solution and one we haven't seen before. On earlier boosters, the grid fins were mounted above the tank dome and never risked contact with cryogenic fluids. By enclosing the fin actuators, SpaceX also eliminated the need for complex rotary seals, reducing failure points and simplifying maintenance. Now, as for the upper stage, or the ship, SpaceX has optimized its internal layout to increase fuel capacity from 1,500 to 1,600 tons, without changing the vehicle's height or diameter. That extra capacity makes all the difference. With full tanks in low Earth orbit, a refueled Starship could have just enough propellant to reach Mars. Roughly 1,200 tons of that would be consumed for the key engine burns. The trans-Mars injection, mid-course corrections, and the controlled descent onto the Martian surface. By the time Starship begins re-entry, it would still have 300 to 400 tons of fuel left, enough to land a 100-ton payload safely and even reserve propellant for a future ascent from Mars. So, while it's only a 100-ton increase in total fuel, that small improvement provides the energy needed for complex maneuvers, precision landings, and ultimately lays the foundation for SpaceX's first uncrewed Mars missions, targeted for 2026. Of course, to survive re-entry, SpaceX has also upgraded Starship's heat shield for version 3. Re-entry is one of the most dangerous phases of any mission when the vehicle slams back into the atmosphere of Earth or Mars, facing extreme heat and atmospheric drag. That's where the Thermal Protection System, or TPS, comes into play. For future versions, SpaceX is reportedly experimenting with a multi-layer heat shield design. This could include a white felt insulation layer combined with a black ablative membrane beneath the ceramic tiles. If a tile falls off, that black membrane acts as a sacrificial layer, burning away to absorb the heat, while the white insulation underneath helps keep the underlying structure cool. This layered design also seals the tiny gaps between tiles, reducing heat leakage and preventing tiles from loosening or cracking during re-entry. It's a subtle but crucial change that could make the next generation Starship far more durable for repeated deep space missions. Next up is a major upgrade that almost everyone's been waiting for: the new Orbital refueling system. This focuses on the upgraded docking adapter, located near Starship's payload bay. It's now equipped with precision alignment ports, dedicated transfer valves, and low-temperature resistant plumbing to handle cryogenic propellant. Compared to version 2, which only had early prototypes used mainly for testing heat shields and aerodynamics, Starship V3 introduces a fully functional, two-way docking mechanism. That means both the tanker and the receiver can connect autonomously in microgravity, using LiDAR sensors and advanced avionics to align within just a few centimeters. The system also includes cryogenic pumps and insulated transfer lines, capable of moving 150 to 200 tons of propellant per session, fast enough to minimize losses from boil-off. According to SpaceX's plan, a Mars mission will require about 4 to 6 refueling flights in low Earth orbit to fully fill the upper stage's 1,200-ton propellant load. That puts enormous importance on the reliability of this docking adapter. It has to perform flawlessly under high pressure and extreme temperature swings. The reason this system matters so much is simple. It solves the energy problem. Starship can't possibly lift all 1,600 tons of fuel from the ground in one go. But with orbital refueling, it can reach escape velocity, 11.2 kilometers per second from LEO, and carry out key maneuvers like trans-Mars injection and a controlled landing on Mars. Without this system, a crewed Mars mission would be impossible. But with Starship V3, it's finally within reach. And 2026 could be the year SpaceX makes history again. So, if you haven't already, make sure to subscribe to Alpha Tech. We'll be right here following every milestone on SpaceX's path to Mars. Beyond all the big upgrades for Mars missions, SpaceX has also made a few smaller, but still meaningful changes. Starting with the Super Heavy booster, one of the key improvements lies in its redesigned grid fins, now larger, stronger, and more aerodynamically efficient. The number of fins has been reduced from 4 to 3, arranged in a T-shaped configuration around the vehicle. This new layout not only improves control during descent, but also lines up perfectly with the catch arms on the launch tower, allowing smoother, more precise recoveries. The International Space Station, a symbol of global cooperation and the pinnacle of human engineering, has been orbiting Earth for over 24 years. It's a massive structure, made up of 17 main modules, each launched and carefully assembled over 2 decades, forming a pressurized volume of about 935 cubic meters, roughly the size of a large house that could fit around 40 people. But here's something most people don't know. SpaceX is quietly preparing to break that record. Imagine a single giant spacecraft, not modular, not assembled piece by piece, just one launch, and it's ready to operate in space. A ship with an interior volume even larger than the ISS, reaching over 1,000 cubic meters. And this isn't speculation. SpaceX is actually working on building that spacecraft. It's called Starship version 4. Elon Musk first hinted at this design a few weeks ago during a live stream update, where it was introduced as the future Starship, a massive vehicle that, when stacked, would reach an incredible 142 meters in height, expected to debut around 2027. It wasn't until later, when Musk released a full comparison chart of all Starship versions, that the name version 4 became official. Basically, it's the upgraded successor to Starship Vi-3, which is set to launch later this year or early next year, but V4 takes things to a completely new scale. Just the upper stage alone, the ship will stand 61 meters tall, about 9 meters taller than V3, while keeping the same diameter. This crazy design gives the vehicle a total internal volume of around 3,500 cubic meters, with about 1,000 cubic meters of habitable space, noticeably larger than the entire International Space Station. As Elon Musk recently said, the Starship V4 crewed variant will have over 1,000 cubic meters of pressurized volume, about 10% more than the space station. That also means V4 will have roughly 150 times the internal volume of the Apollo lunar module. Think about that. For decades, sci-fi movies imagined that future landers would be maybe 10 times bigger than Apollo's. But SpaceX is skipping an entire generation of progress and jumping straight to massive, fully reusable, multi-purpose spacecraft. In other words, SpaceX is about 20 years ahead of schedule. Oh, and almost forgot. That extra height also boosts its fuel capacity from 1,600 tons to 2,300 tons. To handle that much propellant, the ship will also be equipped with 9 engines, 6 optimized for vacuum, and 3 for sea level, dramatically improving performance in deep space. That's especially crucial for future missions to the Moon and Mars. With 9 engines, the ship will generate a total thrust of around 2,700 tons, force right after stage separation in near-vacuum conditions. This extra thrust helps the vehicle escape Earth's gravity well faster, cutting down on flight time and minimizing gravity losses, especially during the early phase of ascent after booster separation. That also means it can carry even more payload. And you know how it goes. The more you can carry, the cheaper each mission becomes. According to SpaceX's latest update, Starship cargo flights to the Martian surface for research, development, and exploratory missions start in 2030 at a rate of $100 million per metric ton. That's incredibly cheap for something that has to travel 56 million kilometers to reach Mars. At this pace, China will be left in the dust. On top of that, having more engines gives Starship better engine-out capability, meaning if 1 or 2 engines fail, as has happened before with Falcon 9, the spacecraft can still complete its mission and even land safely. That's a huge advantage for future human-rated versions, drastically reducing risk for crewed missions. And since this is the crewed Starship, it'll also need ceramic heat shield tiles for Mars missions. Unlike the lunar version, Starship HLS, which doesn't require them because the Moon has virtually no atmosphere, Mars is a different story. The red planet's thin atmosphere is about 95% carbon dioxide, with a surface pressure only 0.6% that of Earth. When a spacecraft enters at speeds of around 7 to 8 kilometers per second, that CO2 still creates enough friction to heat the surface up to nearly 1,400 degrees Celsius. It won't be as dramatic as the glowing plasma scenes we saw during Flight 10 and 11, but it's still hot enough to melt most materials. So, how can SpaceX actually send such a massive spacecraft all the way to Mars? Well, the first step is upgrading Mechazilla, the giant launch tower that stacks and catches Starship. The new version will support Super Heavy Block 4 and Starship V4, both of which are significantly larger and more powerful. This upgraded booster will produce a staggering 10,000 tons of thrust, up from roughly 7,500 on Block 1. It'll likely use 33 Raptor V3 or even V4 engines, along with structural improvements that boost its payload capacity to about 250 tons to low Earth orbit. To handle all that, Mechazilla itself is getting stronger, its chopstick arms reinforced with high-strength steel alloys to safely catch the heavier booster. The tower's hydraulic systems are also being upgraded to handle greater vibration and stress, ensuring a precise catch just minutes after launch. The orbital launch mount is being redesigned too, with new water-cooled steel plates to withstand the massive heat and pressure from 33 Raptor engines firing simultaneously. And the propellant farm at Starbase is expanding to hold up to 5,000 tons of liquid methane and liquid oxygen for each launch, enough to fuel Super Heavy Block 4 to send Starship V4 into orbit with its full payload. Once stacked and ready, the launch begins. All engines ignite, lifting the entire 142-meter-tall stack off the pad. About 2.5 minutes later, Super Heavy shuts down and separates at roughly 70 kilometers altitude, flipping around and heading back to Earth. Just minutes later, Mechazilla's arms reach out to catch the booster, ready to be reused almost immediately. Meanwhile, Starship V4 continues its climb, firing up its 6 vacuum-optimized Raptors to reach low Earth orbit, around 200 to 250 kilometers high. And once it's there, it gets ready for the next crucial step: orbital refueling. SpaceX expects to need around 5 to 10 tanker launches to fully refuel a single Starship depot, essentially an orbital gas station. These tanker ships will dock at the rear of the depot using upgraded propellant transfer ports, allowing liquid methane and oxygen to flow between the two vehicles in microgravity. The entire process could take several days to a week to complete. Once the crewed Starship V4 docks with the depot, it'll top off its massive propellant tanks. Then, the two ships separate, and Starship begins one of the most critical burns of the entire mission. With a delta V of around 6 kilometers per second, it performs the Trans-Mars injection, a long engine burn that pushes it out of low Earth orbit and sets it on a trajectory toward Mars. That single maneuver marks the beginning of a journey spanning over 56 million kilometers, carrying the first steps of humanity's expansion beyond Earth. The journey to Mars will take roughly 6 months, following what's known as a Hohmann transfer orbit, the most fuel-efficient path between two planets. During that long cruise, the crew, likely 4 to 6 astronauts, will live and work inside Starship's massive 1,000 cubic meter pressurized cabin. They won't just be sitting around. Their daily routine will include scientific research, such as running microgravity physics experiments, monitoring the spacecraft's systems, and preparing equipment for surface operations once they reach Mars. They'll also maintain critical systems like solar power arrays, water recycling units that reclaim up to 90% of onboard water, and life support modules that generate oxygen through water electrolysis. Just like on the ISS, exercise is essential to prevent muscle and bone loss in microgravity. The crew will train on treadmills, resistance machines, and other countermeasure devices. Communication with Earth will continue through laser or radio links, similar to how NASA stays in touch with the Perseverance and Curiosity rovers on Mars. And to keep morale high, astronauts will have access to books, movies, or even virtual reality entertainment to pass the time. Because of the immense distance from Earth, radiation exposure becomes a major concern. Levels can reach up to 10 times higher than on Earth. To counter that, the crew cabin will be surrounded by radiation shielding, using water or polyethylene layers and even the propellant tanks themselves as added protection. Throughout the flight, Starship V4 will automatically adjust its trajectory using its Raptor engines or small attitude thrusters, fine-tuning its path and avoiding potential collisions with micrometeoroids as it sails millions of kilometers through deep space. Now here's where things get really intense. As Starship V4 approaches Mars, it begins the most dangerous phase of the entire journey, atmospheric entry and landing. If everything goes according to plan, the spacecraft will perform the legendary belly flop maneuver, tilting its body about 40 to 60 degrees to maximize drag, slowing down from 7 kilometers per second to around 1 kilometer per second. But because Mars's atmosphere is so thin, aerobraking alone isn't enough. That's where retropropulsion comes in. 3 sea-level Raptor engines ignite for about 1 to 2 minutes, providing the final braking burn for a precise touchdown. The flaps, controlled by onboard AI, constantly adjust to keep the ship stable even in unpredictable Martian winds or sandstorms if they happen to hit. Starship targets flat landing sites like Jezero Crater or Utopia Planitia, regions with stable terrain and subsurface ice, perfect for long-term missions. Just before touching down, the landing legs deploy, the Raptors throttle down, and the ship settles softly at less than 5 meters per second, bringing its crew and 100 tons of cargo safely to the surface. Once on the ground, Starship V4 transforms from a spacecraft into a fully functional Mars base, providing shelter, power, and resources to produce methane and oxygen fuel from carbon dioxide and water ice through the Sabatier process. That's the foundation of SpaceX's long-term goal, to make Mars self-sustaining. The crewed version will also include an elevator system, similar to the HLS design, for moving astronauts and equipment in and out of the ship. And guess what? The first payload Musk wants to send isn't a billion-dollar NASA instrument. It's Optimus, Tesla's humanoid robot. As Musk said himself, slight chance of Starship Flight to Mars crewed by Optimus in November or December next year. A lot needs to go right for that. He added, more likely first flight without humans in approximately 3.5 years, next flight approximately 5.5 years with humans, Mars city self-sustaining in 20 to 30 years.